सचिन पुजेरी, अभिनंदन शिरहट्टी, अभिनंदन, अभिनंदन, ओके राइट। अभिषेक कागवाड़, अभिषेक,
सर अभिनंदन शिरहट्टी।
अक्षता, I have marked your attendance. अक्षता बेळवी,
Present, sir.
ओके। आनंद क्याबानी, आनंद, अंजुम बिरादर,
Present, sir.
अंजुम,
Present, sir.
ओके राइट। बसवराज, बसवराज, बसवराज गडकरी, बसवराज ऐनापुरे, बसवराज ऐनापुरे, भाग्यश्री मठ, भाग्यश्री, भक्ति,
Present,
भक्ति,
sir. Present, sir.
ओके राइट राइट। भारती हादिमनी, भारती, भारती, चेतन कुमार,
प्रेजेंट सर।
ओके। दीपक, दीपक जामदार, दिव्या कुलकर्णी, दिव्या कुलकर्णी, गढ़ प्रथमेश शिवाजी,
प्रेजेंट सर।
ओके। ज्योति ओलेकर, ज्योति, किरण लिगाड़े, किरण, लक्ष्मीकांत कालोजी, लक्ष्मीकांत, मांतेश पाटिल,
यस सर।
ओके। मोळे प्रेम, मोळे प्रेम, नागेश, नागेश तोडशिवण्णवर, नंदीश,
प्रेजेंट सर।
ओके। पूजा पाटिल, पूजा, पूजा पाटिल, somebody had joined Pradnya Patil, Pradnya Patil, somebody had joined, no? In the name of Pooja Patil, what happened? Pradnya Patil, somebody joined, right? Just check. Pramod Kumar Hunshal, Pramod Kumar Hunshal, Praveen Magdum, Praveen Magdum, Priyanka, Priyanka, संध्या, संध्या शिरोडकर, संतोष पुजारी, संतोष, संतोष, संतोष सोनार, संतोष सोनार, शाबाज,
प्रेजेंट सर।
ओके। शफिया, शफिया, राइट।
Present, sir.
श्रीधर, श्रीधर, सृष्टि,
Sabya Patil present, sir.
ओके। पूजा पाटिल प्रेजेंट,
Yes, sir.
ओके फाइन। सिद्धार्थ वर्णेकर,
प्रेजेंट सर।
ओके। सिद्धार्थ पाटिल,
प्रेजेंट सर।
राइट। सुप्रिया,
Present, sir.
राइट। वंदना,
Present, sir.
राइट। वसंत, वसंत, वेददत्ता, वेददत्ता, योगेश, योगेश, योगेश नॉट देयर, देशमाने, महेश दोडमनी, महेश,
सर। यस सर।
ओके। बाळेश, बाळेश, Taik Mohammed, Taik Mohammed, Praveen Rathod, Praveen, Abhishek Palekar,
Present, sir.
okay, Aishwarya, Aishwarya, Amanullah, Amanullah, Bandodkar Tanay Mohandas, Bandodkar Tanay Mohandas, Bhaurav,
Yes, sir.
right? Desai Shodhan Ashok,
Present, sir.
okay. Devannaur Anil Kumar Shekappa, Devannaur Anil Kumar Shekappa, Nand Kumar Patil, Nand Kumar, Pramod Kesti, Pramod Kesti, Rohini Paule,
Present, sir.
okay. Rohit Alwani, Rohit
Present, sir.
Alwani,
Present, sir.
okay, right. Shashidhar Gaudar, Shashidhar, Sridhar Badger, Sridhar, Saish, Saish Agarwadekar, Snehal Sawant,
Present, sir.
okay. Vaishnavi Sanikop,
Present, sir.
okay. Anybody else joined late?
Sir, 12. Sir, Jyoti. Roll
Jyoti.
number 9.
Roll number 9. It is.
Sir, roll number 16, sir.
Okay, right.
Sir, Bharti.
Bharti, yes. Anybody else? Anybody else? Okay, we'll begin with the today's session. Is my sound echoing? No, no. Is my sound echoing here?
No, sir.
Yes, sir.
It is echoing?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay, 1 minute. Just a minute. Now is it fine? Or still?
Still it is echoing, sir.
Still it is echoing?
Yes, sir.
Okay. Now is it okay? Shodhan?
Yes, sir. Yes, sir.
It's okay, no, no? Okay. Okay, fine. Thank you. Are you able to see the screen?
Yes, sir.
Okay, thank you. The last class I had started with the addressing modes, and we have discussed few of the addressing modes in the last class, starting with the immediate addressing mode, right? Then after immediate addressing mode, next we discussed about register addressing mode, direct addressing mode, indirect addressing mode, okay? Then relative addressing mode, fine, indexed addressing mode. So we had discussed these 6 addressing modes in our previous class, is it not? So what is immediate addressing mode?
Sound lag agate ನೋಡಿ.
ಏನಾತಪ್ಪ? ಏನು ಪ್ರಾಬ್ಲಮ್?
ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಆಗದೆ ಸರ್.
ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಆಗತ್ರಿ? ಹೌದಾ?
ವಾಯ್ಸ್ ಎಕೋ ಆಗ್ತದೆ ಸರ್.
ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಏನಾಗತ್ರಿ ಎಕ್ಸಾಕ್ಟ್? Immediate addressing mode, are you able to recollect what is immediate addressing mode?
Data is stored in the register immediately.
Data is stored in the register immediately. Very good. What is direct addressing mode?
Data stored in memory location.
Correct. Data is stored in one of the memory locations. What about register addressing mode? Register addressing mode.
Data is stored in registers.
Yes, data is stored in the registers. Okay. So such addressing mode is called as register addressing mode. Then come to relative addressing mode. In relative addressing mode, how do we get the target address? How to calculate the target address? How are we calculating the target address in relative addressing mode? We are adding the value of program counter. Program counter stores the memory location of the next instruction to be executed. So that value we are adding with the relative address. Relative address we are getting as the second byte of the opcode. Second byte of the opcode of that instruction. That gives the relative address. Is it not? So that relative address, when we add with the value in program counter, we get target address. Is it not? So like this we are calculating the target address in the relative addressing mode. Fine. Is my sound okay here? Bharti?
Yes, sir.
Okay, no? Right.
Yes, sir.
Okay.
Yes sir.
Okay, thank you, thank you. Next we will move ahead with the absolute addressing mode. In absolute addressing mode, the target address is obtained as bits A10 to A0 of the opcode. Here in absolute addressing mode, target address is obtained as the bits A10 to A0. It is a 2-byte instruction, 2-byte addressing mode. In this type of addressing mode, the opcode bits A10 to A0 will provide the destination address, or they will provide the target address. For example, let us take here A10 to A0. Okay, so here A10, this is A10th bit, this is A0 bit. Okay, so in between they are A9, A7, okay, they are the other bits, right? A10 to A0, right? So after A10 we have A11, A12, A13, A14, A15. It is 16 bit. Is it not? It is 16 bit, 2-byte it is, 2-byte instruction. In that 2-byte opcode, the bits A10 to A0 will store the destination address. Right? These will provide the address where the jump has to take place. Last class we discussed how the jump is taking place, what is forward jump, what is backward jump. All those we discussed in the previous class. Is it not? So here, if I consider the address A10, let us say it is starting with 0, then we have 1 1 1 1 1 1 1. Okay, then next we have 0, then 1 0 1 1, then 1, then 0 1. So we have these 11 bits as 0 1 1 0 1 0 1 1 0 1. Okay, so now what is the memory location here? If this is the bits or the value that is stored in A10 to A0, what will be the memory location? If we want to find the memory location, we have to group them. So what will be the groups? For example, A0 to A3. A0 to A3 is one group. Okay. Then A4, A5, A6, A7, 4 bits. They are in one group. Right? Then A8, A9, A10, A11, A10. Okay, they are in another group. Right? So let us make the group here. So when we group them, how do we get them? A10 to A10, A10 to A10 to, it is A10, A9, A8, A10, A8. Okay, let us write them. It is 0 1 1. So what is 0 1 1? It is 3 in decimal. Correct? It's 3. Then A7 to A4. A7 to A4. It is how much? A7 to A4? 1 0 1 0. Okay, that is A. It is 10. 8 4 2 1. It is 10. This is 8. This is 4 2 1. 8 4 2 1. Weights. So it is 10 means A. Then next A3 to A0. A3 to A0. A3 to A0 is 1 1 0 1. 1 1 0 1. So 1 1 0 1 is how much? 8 plus 4 12. 12 plus 1 13. Right? So 13 is how much? A is for 10, B for 11, C for 12, D for 13. So it is D. So the address of the destination, target address or destination address is how much? 3ADX, hexadecimal. Target address is 3ADH. Okay, like this we will be able to calculate the target address with the help of the bits A10 to A0 of the opcode. What is opcode? Opcode is operational code. It is the machine code of that instruction. Okay, because the microcontroller cannot understand the assembly language, whatever is written by us, like what all mnemonics we are using, ADD, MUL for multiplication, DIV for division, right? We use them in the instruction, is it not? MOV for move. So these instructions, they are nothing but assembly level language. Okay, they are mnemonics, assembly level language, which is understood to us, which is understandable to us. But the microcontroller cannot understand this language. And hence we have to use the machine code. That machine code is given by the opcode or the operational code. For every instruction, there is a particular opcode or the operational code. Right? So among the 12 bits, among the how many are 2 byte means 16 bits. Among the 16 bit, it is 2 byte opcode, that is absolute addressing mode. So in 2 bytes, remaining bits is nothing but the opcode. Right? A11, A12, A13, A14, A15 is the opcode. The bits A10 to A0 give the these bits. These bits give the destination address or the target address. Clear here? So this is how the jump address or the target address is calculated in case of, that is, absolute addressing mode. Is it understood here, students? Concept is clear here? Concept is clear? Yes? This concept is clear here?
Yes, sir.
Okay,
Yes,
right.
sir.
Okay, fine. Then we'll move ahead with the next addressing mode. So next is, so the examples are being given here, instruction examples of absolute addressing mode. A call delay. A call is absolute call. Absolute call delay. AJMP ahead. Absolute jump ahead. Okay. So these are the two instructions which make use of absolute addressing mode. and the jump can take place within 2 kilobytes of memory location. The jump can take place in the program. It is within 2 kilobytes of memory location, within that space, within that range, right? That much is the range of absolute addressing mode. So if anybody asks you what is the range of absolute addressing mode, it is 2 kilobyte. Range of jump of absolute addressing mode is 2 kilobytes within the memory of that particular program. Okay. Next is the long addressing mode. In long addressing mode, the target address is given by second and third byte of the opcode. Long addressing mode makes use of 3-byte instructions. The instructions which are of 3 byte, they are making use of long addressing mode. Okay, so these 3 byte instructions, in this 3 byte, second byte and third byte, that is nothing but the target address. Second byte and third byte is the target address. So like just now how we wrote for the, that is absolute addressing mode, similarly for the long addressing mode also we can write, that is second byte, let us say it is 1011. Okay, it is 8 bits, 1001. Then it is a 2 byte, so it is 1010 Now how much is this? 1011, upper 4 bits, 1011. Okay, it is 11. 11 is B. 11 is B. Then these 4 bits, 1001, it is 9. It is 9. Okay. Then next, these 4 bits are done. Then these 4 bits are done. Next is this 1010. 1010 is how much? 10. That is A. Then next is 1011. 1011 is 11. That is B. It is B9AB hex. B9AB hex is the target address given by the long address mode. I'm just taking an example. This is just an example what I'm explaining here. Okay, these are examples to make you understand the concept. Okay, you can take any other example and you can explain it. Just for explanation purpose, to make you understand the concept, I'm taking these examples and making you understand them. Okay. So this is about the long addressing mode. Instructions which make use of long addressing mode are lcall and ljmp. Lcall means long call and ljmp is long jump. Right? So these instructions, they make use of long addressing mode. And the jump range, the range of the jump is within 64 kilobytes. Within 64 kilobytes of the code memory or the program memory. Okay, that much is the range of this long jump, long addressing mode. For absolute addressing mode, the range is 2 kilobyte of the program memory. For long addressing mode, the range of the jump is within 64 kilobytes of the instruction. Okay, within 64 kilobytes of the code memory or the program memory. Okay. There is difference between call instruction and jump instruction. The difference is, in the call instruction, when the call instruction is used, it will jump to the target address, right? And at that target address, whatever instructions are there, it will execute those instructions, and again it will come back to the main program. It will come back to the main program, just as you write functions in C language. Just as you write functions in C language, you write the main program, right? You execute the function, means it will go to the function part, it will come back, right? When you execute that function, when it is executing the function, again when you execute the last instruction of the function, again it will come back to the main program, and there you are continuing with the execution in the main program. Is it in C language? Similarly here, what is happening is, when the jump takes place, it will jump to the target address, and the target address, which all are the instructions there, it will execute those instructions, right? And then it will return back to the main program, But when it executes the jump instruction, it jumps to the target address. After executing that small program or the instructions which are there at the target address, after executing those, it will not return back to the main program. This is the difference between call instructions and jump instructions. Is it clear here? For call instructions, after executing the instructions at the target address, the microcontroller will come back to the main program. But for jump instructions, when it jumps to the target address, when it jumps to the target address after executing the instructions at the target address, it will not come back to the main program. So just remember this difference between call and jump. Okay. So these are the various mechanism of addressing modes. Can you tell me which addressing mode is the first one? Opcode and data. So the data is stored immediately. It is immediate addressing mode. First one is immediate addressing mode. Okay. We have the opcode, register, and in register data is stored. This is register addressing mode. Register addressing mode. Fine. Then opcode, memory address. In memory location, we are storing the data. If we are storing the data in memory location, it is direct addressing mode. Right? Then we have opcode, register. In register, we are storing memory location. In memory location, we are storing data. Which addressing mode is this? Can you tell me this?
Indirect.
Indirect.
It is indirect addressing mode. Okay, because in indirect addressing mode, what happens in memory location, we are storing the data, and that memory location we are storing in the register. Right? I give the example of move a comma at r0. Okay, in r0, excuse me. In r0 register, we are storing the memory location, say 40h, right? And in 40h memory location, we are storing the value, say 03h. So when I use the instruction move a comma at r0, the value 03 will be stored in the register, that is a register. Okay, move a comma at r0. The value 03 stored in memory location 40h in register r0 will be moved into a register, or it will be stored into a register. Right? So this is indirect addressing mode. Next, we'll take up the opcode, displacement or offset, program counter. It will add the value in program counter to the relative address or to the offset. It is also called as displacement address or relative address or offset. All mean one and the same. Value in program counter is added with displacement address or offset or relative address to obtain the target address. So this is the relative addressing. Relative addressing mode. Okay, students. Then next one is opcode, base register, index register. Register, in register we are storing the index, and in the register we are also storing the base. We are adding these two. Right? When we consider the which addressing mode it is? Indexed addressing mode. In indexed addressing mode, what I give the example of move a comma at a plus dptr or move a comma at a plus pc. Right? Here PC and DPTR, they are called as base registers, and A is called as the index, or it is called as the offset accumulator A. It is called as the index, or it is called as the offset. So the offset is added with the base register in order to obtain the target address. Clear here? So like this, we are calculating the target address in case of the indexed addressing. Okay. Next is the absolute addressing mode. So in absolute addressing mode, we know that the displacement of the offset, it is relative addresses within the 2 kilobyte, range is 2 kilobyte, it will jump within 2 kilobytes of memory. Then in long addressing mode, it will jump within 64 kilobytes of memory location. Right? So these are the 8 addressing modes of 8051 microcontroller. Right? In many of the question papers, they have asked, explain various addressing modes of 8051 microcontroller. So you have to explain each of these addressing modes taking examples. Okay, you have to take 1 or 2 examples and explain all these 8 addressing modes. Right? Let us move on to the next topic, that is assembling and running an 8051 program. Assembling and running an 8051 program. That is when you start, this is in module 2, we are starting with this topic here, assembling and running an 8051 program. In module 1, that decoding part is remaining, considering the 8255 chip, that I will take later because that requires explanation of 8255, which comes in module 5. Okay, so that part, interfacing part, that I will take in the next later modules. Okay, after covering that PPI chip 8255, then I will explain that remaining part in module 1. Right? Next, we'll move ahead with the module 2, assembling and running an 8051 program. Now we have used a few of the instructions like move instruction or MUL instruction, or we have come across div instruction, right? Few of the instructions, instruction, increment instruction, right? Now these instructions, they are assembly level language, because they are mnemonics which are understood to the users. Now in machine level language, for example, for move a comma at r0 or move a comma hash 14h, the opcode that may be used is of 8 bits. It is a 2 byte move a comma hash 14h, 1 byte for the opcode and 1 byte for the data, that is 14h. Okay, so it is a 2 byte instruction. We have come across that when we discussed in the immediate addressing mode, correct? So like this is assembly level language, but when we write in machine level language, it becomes very difficult, right? Can you imagine writing the opcodes, right? Writing the opcodes, is it possible to remember them? It is highly impossible to remember all the opcodes, is it not? Machine codes, we cannot remember them. Hardly we can remember 2, 3 or 4, right? But if we want to remember all the mnemonic, all the that is binary code or the machine code, it is highly impossible, correct? So that is why it is preferable to use the assembly level language which is understood to the user. So assembler, what it will do is it will convert the machine level, that is assembly level language into machine code. Assembler, the function of the assembler is to convert the assembly level language into machine code. Okay, so let us see how to write a program. Then when we write a program here, right, what it happens here actually, what is the process that it goes through till the execution of that program. Now say we are running a stepper motor, right? Let us say we want to control the motor, we want to control the rotation of the motor. How to control that? First we have to write the program, right? Without the program it will not happen, is it not? So we are writing a program for that. After writing the program, so that is called as the editor program. That is the first block which is shown in editor program. This program we are saving it with the extension .asm, like how you save .c files in C language. Similarly, we store them with .asm extension in microcontroller execution, program execution. Okay, so .asm, that is the name of the program that we have written. So once we save it, then the next process is assembler program. Assembler means the assembler, what it will do is it will convert this program, whatever we have written, right, editor program, into obj file and st files, into object code and list file, object file and list file. The object file is nothing but it consists of the machine code. Object file consists of the machine code, and lst file, list file, consists of the compilation process or assembler process of the assembling, how it will take place. All the detailed information is present in the list file, lst file. Okay, then next portion is, next block is linker program. This linker program, what it will do is it will link all these object files. Whatever are the object files generated by this assembler program, it will link all those obj files, right? And it will generate a file called as absolute file. It will generate a file called as absolute file, abs file, with the extension .abs. So this absolute file consists of the memory locations of the program and the data. It consists of the memory locations of the program and the data, right? So these memory locations is fixed. You cannot change it. That is why it is called as absolute file. Absolute file means the memory locations of the data and the program, it is fixed. It is never going to change once it is fixed. Okay, that is why the name given to this file is absolute file. Then this absolute file is further given to OH program. OH program is object to hex converter program. Object to hex converter program. That is, whatever absolute file is there, it will take that and it will convert it into hex file. Hex file, that is, which consists of the hex codes, hexadecimal codes. So whatever program we have written, that is converted into hexadecimal code or hexadecimal language, right? So this hex code is the program that we are going to download into the chip. This hexa program, myfile.hex, we are going to download it into the microcontroller chip. Then when we execute this program, right, that is the program which is downloaded into the chip. When we execute this, the motor is controlled. We are able to control the motor, right? So like this, we are writing the program. This written program is saved as .asm extension assembly program it is. Then this is given to assembler program, right, by the microcontroller, and this assembler program will convert this .asm file to .obj and .lst files. OBJ file consists of the machine code, and LST file, list file, consists of the OBJ file consists of the machine code, and this list file consists of the compilation process. And these are given to linker program. Linker program will link all these OBJ files, and it will convert it into absolute file, ABS file. Absolute file is one which consists of the memory locations of the code and the data. Okay, and this is given to which program? Object to hex converter program will convert this absolute file into hex file. So this hex file is the executable file. It is called as executable file. This is executable file which is downloaded into the microcontroller chip. Once we execute this program which is there in the microcontroller chip, then we'll be able to control any applications. Not only stepper motor, we can control traffic light application. We can control the working of analog to digital converter ADC or DAC or waveform generation. Right? It may be any application we can control by executing the program which is downloaded into the microcontroller chip. Clear here, students? This is understood here, students, how to assemble and run an 8051 program, or what is meant by assembling and running an 8051 program. Is it understood? Yes? Is it understood here? Clear here? Understood, right?
Yes.
Is it understood? Fine. Okay. So the same steps I have mentioned here. Editor is used to create the program, so then it will go through step 1. It converts into machine code. Then assembler will produce OBJ file and LST file. Third step is linking process. Link program takes one or more OBJ files and produces an absolute file with extension EBS. Next, the ABS file is fed into program called as object to hex converter program, which creates a file with extension hex that is ready to burn into ROM memory, or that is ready to be downloaded into the microcontroller chip. So downloading is also called as burning. We burn it is called as burning or downloading it into the chip. Okay, both are one and the same. Next is the data types. We have come across various data types, right? We have seen the bit. Bit means it is single bit, only one bit. Nibble means 4 bits. Nibble means 4 bits. Byte means 8 bits. Byte means 8 bits. And word means 16 bits. Word means 16 bits. But the most common data unit that is used is byte. Right? Nibble is less used. Byte is frequently used because all data transfer that takes place between code memory, data memory, right, and external data memory to CPU, that is in terms of byte. Okay, so byte is most frequently used data unit among all the other 3 data units or data types. Right? Then few of the instructions they operate on single bit. Few of the instructions they operate on single bit. Okay, they are called as single bit instructions. Single bit instruction, that is they operate on single bit. They manipulate the data, that is they perform logical operation on single bit. They perform shift operation on single bit, right? Then they perform set operation, clearing operation of that bit, or testing those bits for jump instructions. For example, if I use JCE instruction, jump if carry. Jump if carry means if carry equal to 1, only then it will jump to the target address. Clear here? So like this, these are instructions which use single bit. Then there are few of them which use 16 bits. For example, DPTR instruction, DPTR register. Okay, DPTR register makes use of 16-bit addresses. Similarly, program counter, it is also 16-bit register. DPTR and program counter both are 16-bit registers which make use of 16-bit addresses. Okay, then if we want to perform 16-bit operations such as 16-bit addition and subtraction, right? For those also instructions are available in 8051 microcontroller, that is ADDC instruction, add with carry and subtract with borrow, SUBB instruction, right? So these instructions help us in calculating 16-bit addition, 16-bit subtraction and other operations. Okay, so that is possible with the usage of ADDC, that is add with carry, and subtract with borrow, SUBB instruction. Add with carry is adding the 2 bytes along with the carry bit. Subtract with borrow is subtracting 1 byte from another byte along with the borrow flag or along with the borrow. That is SUBB instruction. Okay. Next is subroutine. So subroutine definition. First, I will define what is a subroutine here. A subroutine is a small standalone program. It is a small program. Standalone program means it is independent. It is not dependent on any other programs. Standalone program which performs meaningful task that is required by the main program. A subroutine is a small standalone program or module that performs meaningful task or well-defined task mainly needed by the main program. Okay, so just like how you write the main program in C language and the functions, right? So here subroutines are just like functions in C language. Okay, now what is the need for subroutines in programs? Why we should use these subroutines? We should use these subroutines because if there are larger operations to be performed, if it is a complex operation to be performed, then that complex operation has to be broken down into smaller blocks, or they have to be broken down into smaller modules, right? So that these smaller modules are nothing but they are the subroutines. It is a very larger task to be performed, a large job to be performed. So this large job is broken down into smaller jobs, many smaller jobs, so that we can perform these smaller jobs, right, parallelly, and then we can combine their effective results and get the final result. So as the program grows in size, it is necessary to divide large and complex operations into small and simple operations. So these small and simple operations can be programmed as subroutines. We can write a program for these smaller operations or smaller jobs, okay, or smaller tasks. So this practice helps us for better programming to be developed that has many advantages. So this practice of using the subroutines, writing the subroutines, it has many advantages. And what are these advantages of subroutines? Let me list out these advantages. So advantages of using the subroutines. Now, can you tell me what are the advantages? What may be the advantages here? You use the C language, is it not? You use functions in C language, right? What may be the possible advantages here? It is easy to debug, correct? Debugging is easier. Removing the errors will become easier. If you write a large program, say for about 100 lines, it becomes very difficult to debug that program. Debug or removing the errors becomes difficult, correct? So instead of writing 100-line program, if you break that 100-line program into 4 blocks or 4 modules, each of 25 lines, right? If there is any error, you can go to that particular module, you can remove the error, and then you can compile the whole program, correct? So it becomes easier to debug the program. So debugging, editing becomes easier. Then program development time also reduces. It decreases the time taken to write the program or to type the program. Execution of the program time taken is very less. It becomes speed, that is speed of the program execution increases as the programs are written in modular language. That is, if we use subroutines, then the speed with which the programs are written, the executing, that speed also will increase. Programs written are efficient and look elegant. So programs will look nicely written in blocks, right? Within different modules, subroutines, right? So it looks efficient and elegant. Enhances code execution speed. Speed increases, execution speed of the program increases. Enables large tasks to be defined in the main program, and then the application part can be defined in the subroutines. So whichever is the main part of that program, main job of that program or that particular task, that is written in the main program, and the application part, smaller chunk of that program, that can be written as subroutines. Contains code for performing some frequently used operations. So frequently used operations, repeated operations can be written in terms of subroutines, whichever are repeatedly used, so that whenever we require them, we can directly go to the subroutine, we can pick it and then use in our program. We can use it as it is, or we can modify a little bit in that subroutine and we can use it in our program. Okay. So such models can be used with slight modification in other programs. So these are the advantages of using the subroutines. So in examination, the question may be define subroutine and list their advantages. Right? Define subroutine and list their advantages. So this may be the possible question that may come in the examination. Clear here? So next is assembler directives that we will take up in tomorrow's class. So I hope everyone understood here the topics. We started with the remaining addressing modes, that is absolute addressing mode, long addressing mode, right? Then later I explained the mechanism of these addressing modes by taking those figures into consideration. Then after that we came into module 2, assembling and running an 8051 program. We saw the block diagram of assembling and running an 8051 program, right? Then I explained you the steps, right? Then data types, the various data types, that is bit, nibble, byte and word. Then later, what is a subroutine, its definition, need for subroutine and their advantages. Okay. I hope everyone understood here, students. Yes. Was it clear? Was it clear to you all?
Yes, sir.
Okay. Any questions here? Any questions? Concepts were clear to everyone? Concepts were clear, right? Yes?
Yes, sir. Yes, sir.
Okay, fine. Okay. Then we'll wind up the session. We'll continue in the next class. In the next class, I'll be explaining about the assembler directives. We'll complete that assembler directive part in the next class. Okay. Thank you.